So, number one, how can we represent the large one as a power of 10? Well, the large one has a 10 by 10, right? So if I wanted to represent 10 by 10 as a power of 10, 10 squared. 10 times 10 is 10 squared. If each small square represents 10 squared, this is where things get fun. And to problem solve this, I'd write like a little 10 squared there. Now what's going to happen to that 10 squared to get to the medium one? Who can explain what happens? So I'm at 10 squared. How do I get from that to the medium one, Ivy? Okay, so I'm going to multiply by 10 because there's 10 of those little squares. And how many total squares do I have then? 10 cubed. I'm going to write that right there. Now, to go from this to the large, how many 10 cubes are on the large one? I've got 10 of those sticks in the large one, right? So the large one would be 10 to the 4th. Okay. Cool. Looking next, we're going to redo our values of our models. This one's 10 to the 5th. So to go from this one to the large one, what am I going to do to 10 to the 5th? And what's happening here is 10 to the 5th means I have 5 factors of 10 times an additional factor of 10 means I have 6 factors of 10, which is 10 to the 6th.
Oh, I did 10 to the 6th.
Now, how do I get to that small one? Ivy, what do you think for the small one? Divide by 10. So check this out. I'm at 10 to the 5th. I'm going to divide by 10. That would leave me the small one as 10 to the 4th. Now, here's what I want to look at before we do anything else. I want to start establishing like a rule or pattern. It looks like when I had 2 and 1, I ended up with 3. When I had 3 and 1, I ended up with 4. When I had 5 and 1, I ended up with 6. What's happening over and over here? What am I doing with my exponents? I'm adding them. So maybe that's the rule, maybe not. They all just keep being ones. So we'll have to explore that further. But let's look at this going the other way. We know division undoes multiplication. So what did I do to go from 5 to the single? What did I do to my exponent to go from 5 to the single?
Divided by 10.
I divided by 10, but what did I do with my exponent? Minus 1 instead of add 1. Well, let's look at why. What is 10 divided by 10? Not asking a hard one there, friends. What's 10 divided by 10? 1. And so if I divide by this 10, one of these factors of 10 turns into a 1. Right? There were 5 factors in the numerator. If I divide of those 5, I'm going to take one of them and divide by 10. That's going to be 1, so I just canceled it. That's why subtraction worked. We'll do more on that later. So let's put this rule to work. If I have 10 to the 100th down here, I divide by a 10. I get to 10 to the 99th for the stick. And for the single, I get to 10 to the 98th. Why are 10s kind of nice to mess with? We're just talking decimal moves right here, right? So big idea that I want to take away, and we're going to see if it worked. When we multiplied by additional factors of 10, we added exponents, right? You guys ready to test that out to see if it works? It looks like it works. Let's see if it works. So let's explain what this table is doing here. I have an expression, 10 squared times 10 cubed. If we think about what this looks like expanded, 10 squared is 10 times 10, and 10 cubed is 10 times 10 times 10. What is the only operation happening up in here? Multiplication. And the commutative and associative properties of multiplication say, order doesn't matter. I do what I want. We don't need parentheses. It doesn't matter. So, how many factors of 10 are here? 5. Now, let's test out our theory from what we were just looking at. Do we get there by adding exponents? 2 plus 3? Ooh, nice. So I want you to take some time, fill out the rest of this table. But before you finish the last line, I want you to read letter B on your packet. All right, so 10 to the 4th, I got 1, 2, 3, 4. 10 to the 3rd, I got 3 factors.
I did it.
A total of how many factors there?
I did it.
7. So 10 to the 4th, I should write it like they wrote it. 1, 2, 3, 4. And 1, 2, 3, 4. So 4 factors of 10 and 4 factors of 10 gives me a total of 8 factors of 10. What do I have going on next? 3 factors, that'd be 10 cubed. And I've got 5 factors, that'd be 10 to the 5th. 10, what? The same answer twice? Who can give me another way to get 10 to the 8th? Just for fun. Vinny, what are you thinking?
You just do straight 10 times 10 times
10 to the 1st times 10 to the 1st times 10 to the 1st? Okay, I don't have room to write that. Do you have another one? So I got a 10 to the 4th times 10 to the 4th. 10 cubed times 10 to the 5th. Can you think?
10 to the 4th times 10. What's this?
No, I think we got that. What do you think, JP? Yeah, that gets us 10 to the 8th. Who's got another one? Sean?
10 to the 6th plus
Times
10 squared.
Times 10 squared, yeah. I've got one just for you to think about, but I'm not going to tell you if it works or not. What about 10 to the negative 10 times 10 to the 18th? Do they add to be 8?
What?
Do they add to be 8?
You get the point.
Hey, shh. I'm asking you guys a question. I'm not going to tell you the answer, but do those add to be 8, my exponents?
No.
Negative 10 and 18 doesn't add to be 8? Just think about it. We'll come back to that another day. Okay, and then let's expand this last one. Okay, so I got 10 to the 41st. So do you see why we want to get that general rule of adding our exponents? But you need to remember, the reasons we can add the exponents is all we have are all these factors of 10s. So we can kind of tighten up by saying we have this many factors of 10s. All right, does that make sense, everybody? Can I head in there?
Yeah, I see that.
So what I do is I never write it expanded for the most part, but sometimes if I'm like, which rule should I use? I imagine what it would look like expanded. It doesn't make, I know it doesn't seem like you're like, I'm not going to mess this up. I'm straight up just adding. But I'm going to let you know there's like other exponent properties we're going to look at, and it's when you put them all together. If you're a memorizer like me, when I took 8th grade algebra, I did not do well on this test. But then in advanced algebra, when I decided not to memorize and understand, it's like easy. So I'm gonna say keep making sure you focus on concept, because if you focus on concept, the rule comes to you. Versus trying to memorize when it looks like this, do this. Those kids struggle. All right, and like I've been doing this long enough. I see the same thing every year. The kids that go by concept do really well and think it's easy. The kids that memorize really struggle. So just take my advice early on here. Kim. So going right here to 2a. 10 times n times 10 to the nth times 10 to the mth. How could I simplify that as one expression? I guess it already is an expression. As a tighter expression, how can I simplify it? Ivy? Yeah. N plus m. We were adding our exponents. So this is the rule we just generated from all of our experiences. This letter B is real fun. So we're adding exponents when our bases are the same. So 10 to the 4th times 10 to the 0, I add my exponents, that should be 10 to the what?
4.
10 to the 4th. Now let's think about this though. What does 10 to the 0 have to equal then, if I were to evaluate it?
0.
Okay, so people say 0 every hour today.
It's 1.
But times 0, it equals 0. It has to be.
It
It has to be 1. Because 10 to the 4th times 1 equals 10 to the 4th.
Good job, Troy.
So that's one way I'm going to prove the 0 power 2. Here's another one. Yeah, it has to be, right? 10 to the 4th times 1 equals 10 to the 4th, right? Well, 10 to the 4th times 10 to the 0 also has to equal 10 to the 4th. 10 to the 0 has to equal 1. Here's another way I can prove the 0 exponent to you. That all the 0 exponents equal 1. Follow me here. 2 cubed equals what? 8. 2, 4, 8. 2 squared is? 4. 2 to the 1st is? What's happened to all my answers?
They're decreasing by
They're dividing by 2, right? So 2 divided by 2 is? 1. So 2 to the 0 has to be? 1. That's another proof. Okay? It can't be 0 because that would mean there's no factors, or no factors of anything. But, yeah. Kind of cool, huh? Gut bacteria here.
Oh, disgusting.
Okay, in Georgia, there's 10 to the 7th people, and each person has 10 to the 3rd bacteria. So here's what I want to ask you.
10 to the 13th.
10 to the 13th.
Yep.
10 to the 7th people, each has 10 to the 13th. How many bacteria is that? The answer is 10 to the 20th. So would you rather use our exponent rule or do this?
Well, that looks
Which one of these looks easier to do?
left side.
10 to the 20th, right? So a lot of math we build in things for efficiency purposes, right? I can look at it and give you an answer 10 to the 20th. Or I could write zeros all day and probably forget one. Yeah. So again, let me reiterate what happened there. You guys, a lot of you said 10,000 cubed. Cool. I said 10 to the 12th because I did 10 to the 4th times 10 to the 4th times 10 to the 4th. Each of those is 1,000. That is 1,000 cubed, right? And we said, hey, from our last lesson, we have 4 factors of 10, 4 factors of 10, and 4 factors of 10 for a total of 12 factors of 10. I can add exponents. But because you guys brought up this cube thing, I was like, hey, I've got 10 to the 4th cubed here. I want you all, 30 seconds, try to give me a rule for us to test out for the 4 and 3 to get us to this answer. Ivy. Oh, multiply them. And as I was talking to this table, check it out. This right here is repeated addition. Repeated addition, 4 plus 4 plus 4, right? What is repeated addition? Multiplication. That's why this is multiplication. So, again, some of you are going to be tempted to be like, it looks like this, I multiply. Okay, you could do that. But you're going to mix it up at some point and get a bunch of junk wrong. If I see this, I kind of in my head recognize I have 10 to the 4th 3 different times. That repeated addition is the multiplication, then I multiply. The understanding takes me to the what to do versus just trying to remember what to do. Let's take that here. Oops. Yeah. So let's do one row of this together. So I've got 10 squared to the 5th. And what that means is I have 10 squared these 5 times. How many total factors of 10 are there? 10. There's 10, so it's 10 to the 10th. You can do 2 plus 2 plus 2 plus 2 plus 2, but repeated addition is multiplication. Yep. So fill out the rest of the table as a group. Here we go. 10 to the 4th squared means 10 times 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 10 for a total of 10 to the 8th. Who can give me 10 to the 8th, the 2 exponents, a different way? Anybody else get it a different way? Yeah, Brandon. It's actually not. Let's get 10 to the 12th a different way. There's more options. Brandon.
10 to the 12th.
Yeah, how do I get to 10 to the 12th using an exponent to it, a power to a power?
10 squared with an exponent of 6.
Who's got another one for me to try by raising their hands? What's another combination I can get to 10 squared? Sean?
10 cubed times 4.
Or 10 cubed to the 4th. We did that one, but it does work.
Well, 10 to the 4th.
Yeah, 10 to the 4th cubed. Okay, here's one to mess with your minds. Let's see if this works. 10 to the negative 2 times 10 to the negative 2 to the negative 6?
Yep, I get it.
Negative 2 times negative 6? Yeah, that actually gets it done.
Equals a positive.
10 to the 1st to the 12th, yep. 10 to the 0 to the 12th would be 0 times 12.
That would be 10.
Yeah, I like that.
It would be 10 times. But I thought it was 1. Like 10 to 0 is 1.
So it's equal to 1. Hey, we've got a good question here by Ivy. She said, what about 10 to the 12th to the 0, right?
That's 0.
Okay, but anything to the 0 power is 1. It doesn't mean it has an exponent of 1. It actually is 1. That's the difference. Yeah, so this would equal 1. So that wouldn't work, but I like that you tried it out. Yeah, it is 1 versus an exponent of 0. Cool. So, yeah, it would not be fun to write out 88 factors of 10. So let's just power to a power. We multiply. And remember, the reason we can multiply is we have that many repeated additions happening. Repeated addition is multiplication. Do you see how, like, as we add more and more rules, if you're just trying to memorize stuff, you're going to, like, mix them? Like, add sometimes, multiply other times, where if you understand what's happening with the expansion, it'll make that come to you. Taking a look at this rule here. 10 to the m to the n. How can we simplify that expression? What's equivalent as one expression with 10 as our base? When we have a power to a power, what do we do with the powers? When we would just do it. When we had a power to a power, what do we do with our numbers? Multiply them. So guess what I'm going to do with m and n? Multiply them. 10 to the mn. A power to a power, we get that repeated addition. That means we multiply. Guys, this oil thing is crazy. I'm hoping the numbers are real. But they're saying in a 2-month period, there's a 10 cubed nature meters on each side of a brick of oil used. So 10 cubed doesn't sound that crazy, right? Of oil used. But this is really 1,000 times 1,000 times 1,000. Or the volume would be 10 to the 9th. Right? 10 to the 9th cubic meters, which is 1 billion.
1 billion? Oh my gosh, that's about almost as much money as that.
Cubic meters. 1 cubic meter is like, meter by meter by meter. My car, by 1 cubic meter, can get filled like 19 times. I did the math earlier today. Just 1 cubic meter would fill my car 19 times, which is like, let's say, a little over 8 times a
What kind
month.
of car do you have?
A 2007 Ford Freestyle.
2007?
It's a real beater. I love it. Anyway,
Can you off-road it?
you do whatever you want with your
Better
car.
off-road
When you
it.
have a
I just
junker
want my
car, you
off-road
do whatever
license.
you want with
I
it.
just
But
want my OR fee.
no, just put this in context. That is just one of those cubes. This is 1 billion of those cubes in 2013. And I would imagine more than that in 2021. Maybe I'm wrong, though. There's like electric vehicles, but also expanding countries, other places. I don't know. That's a whole lot of oil.
Hold on.